A copper sheet costs $2. It passively heats a room to comfort temperature using only sunlight, no electricity, no gas. FEMA classified installing one as a structural modification. That classification makes it functionally illegal in emergency shelters. A commercial solar thermal installation runs $3,000 to $8,000. The components for this build cost under $25. The heating industry does $7 billion in annual revenue. A $25 panel threatens none of it. By the end, you'll know the exact build. Frame dimensions, absorber prep, glazing, vent placement, and optimal angle for your latitude. Here's what they don't want you building. If you're the kind of person who wants to know what works before the lights go out, you're in the right place. This channel doesn't do product placements. We don't sell prepper kits. We recover buried practical knowledge and hand it to you. No fluff. Just what works when systems fail. Subscribe if that matters to you. The algorithm doesn't favor content like this. We have no marketing budget. We have you. Let's start with why copper. Copper conducts heat at 401 watts per meter Kelvin. Aluminum conducts at 205. Steel manages 50. That's not opinion. That's material science. When sunlight hits a copper plate painted matte black, that plate absorbs thermal energy and transfers it with ruthless efficiency. The Thermosyphon principle does the rest. Heated air rises. Cool air is drawn in from below. The cycle continues as long as the sun shines. Continuous passive circulation. Zero electrical input. No moving parts. No fuel consumption. The Department of Energy Solar Energy Technologies Office has documented collector efficiency for decades. A properly built absorber plate reaches 150 to 200 degrees Fahrenheit under direct sunlight. The air exiting the system measures 100 to 140 degrees. This isn't experimental technology. It's physics that's been understood for over 200 years. The Thermosyphon principle was documented in Roman bath engineering. 18th century European hotbox collectors used the same convection mechanics. Passive solar collection experiments date to the 1760s. The science hasn't changed. Heated air still rises. Copper still conducts. Sunlight is still free. What you're watching right now is the surface. The vault contains the full library. Bill guides, historical archives, suppression documentation, disaster case studies. No filler, no fluff. Links below, but stay here. Everything you need for this build is in this video. Now let's talk about what happened in Texas. February 2021, temperatures dropped below zero across Texas. Natural gas wellheads froze. Gas pressure dropped statewide. The electrical grid failed. 4.5 million homes lost power. 246 people died. Every one of those homes had a furnace. Not one of them had heat. They depended on a centralized system with a single point of failure. When the grid collapsed, the heating collapsed with it. Families froze in their own living rooms while the infrastructure they trusted completely abandoned them. A passive solar air heater operates independently. No gas lines. No electrical grid. No supply chain. As long as the sun rises, it produces heat. The day after the Texas grid failed, the sun still came up. The sun still hit south-facing walls. The Thermosyphon principle still worked. But those families didn't know how to build one. No one had told them it was possible. Every one of those 246 deaths was a failure of centralized dependence. Your family doesn't have to repeat that mistake. The knowledge exists. The materials cost $25. The build takes one afternoon. So why isn't everyone building these? FEMA, Emergency Shelter Habitability Standards, classify solar thermal panel installation as a structural modification. Read that again. Structural modification. Not an appliance, not a heating device. A structural modification. That classification triggers code compliance review. It triggers permitting requirements. In most jurisdictions, it requires a licensed contractor. A $25 copper panel now costs hundreds in permits, hundreds more in professional labor. The classification doesn't ban the technology. It just makes it prohibitively expensive and bureaucratically complex for the people who need it most. This isn't speculation. It's documented FEMA policy language. The classification exists in black and white. The effect is the same as a ban. Now ask yourself, who benefits? The commercial HVAC industry generates $7 billion annually in the United States residential market alone. Their business model depends on equipment sales, installation contracts, recurring maintenance, and fuel dependency. Natural gas utilities profit from every therm you burn. Electricity companies profit from every kilowatt hour your heat pump consumes. A $2 copper sheet breaks that cycle. No installation contract, no maintenance plan, no fuel bill, no proprietary components, no patent, no recurring revenue. Copper is an element. You can't patent an element. The Thermosyphon principle is physics. You can't trademark physics. Matty black paint is generic. There's nothing to own, nothing to sell repeatedly, nothing to build a quarterly earnings report around. The classification isn't a conspiracy. It's a regulatory structure that happens to align perfectly with the profit incentives of a $7 billion industry. Whether that alignment is intentional or accidental, the result is identical. The cheapest solution stays out of emergency shelters. This is the kind of knowledge that doesn't show up in your feed unless you subscribe. Hit that button. We don't have a marketing budget. We have you. Before the build, let's be honest about what this panel can't do. Solar air heaters produce zero heat at night, minimal heat on overcast days. They supplement heating systems. They don't replace them in sustained cold. Thermal mass like water jugs or concrete can extend heat delivery but won't carry through a full night in sub-zero conditions. The Thermosyphon effect requires a temperature differential. In mild weather, output is negligible because it's unnecessary. This is a resilience layer, not a primary heating system. Copper is optimal, but aluminum works at roughly half the conductivity. The principle remains the same. Our ancestors understood this. They used passive solar heating as one tool among many. They combined it with thermal mass, strategic building orientation, and insulated construction. They didn't expect one solution to solve every problem. Neither should you. But when the grid fails and the gas pressure drops, this panel still works. That's the difference between freezing and comfort, between dependence and resilience. Now let's build it. Materials you need. 1 copper sheet. Hardware stores sell them for $2 to $3. 4 feet by 2 feet is a good starting size. Dimensional lumber or aluminum angle for the box frame. $8 to $12 depending on scrap availability. Matte black high temperature spray paint, $4. Polycarbonate or glass glazing panel, $5 to $8. Weather stripping, screws. Total cost, $15 to $25. Construction sequence. Number 1, build the shallow box 4 inches deep. Size it to your window or wall opening. The box holds the absorber plate and creates the air channels. Use basic carpentry. Corners don't need to be perfect. They need to be sealed. Number 2, cut and prep the copper absorber plate. Sand lightly to remove oxidation. Degrease with alcohol. Apply 2 coats of matte black high temperature paint. Let dry completely. The matte finish is critical. Glossy paint reflects light. Matte absorbs it. Number 3, mount the absorber plate inside the box. Leave 1 inch of clearance behind the plate for the airflow channel. Leave clearance above for the heated air to rise. The copper shouldn't touch the box walls. Air needs to flow around it. Number 4, install intake vent at the bottom and outlet vent at the top. These connect to your interior room. The intake pulls cool air from the room. The outlet delivers heated air back. Vent size matters. Too small restricts flow. Too large loses heat. 2 to 4 inches in diameter works for most builds. Number 5, seal the polycarbonate glazing over the front of the box. This is your solar window. It traps heat while letting light through. Glass works but weighs more. Polycarbonate is lighter and doesn't shatter. Seal all edges completely. Number 6, mount at optimal angle for your latitude. Take your latitude in degrees. Subtract 15. That's your winter optimization angle. A steeper angle captures low winter sun. You can mount vertical if angled installation isn't possible. You'll lose some efficiency, but the principle still works. Number 7, seal all edges with weather stripping. Any air leak is wasted heat. Check seals twice. Observable results? Air exiting the top vent will reach 100 to 140 degrees Fahrenheit on a clear day. You'll feel the convection current within minutes of direct sunlight hitting the panel. The room temperature rise depends on room size and insulation, but expect a noticeable difference within an hour. Gary Reisa documented this exact build on Build It Solar. His panel heated a workshop from 45 degrees to 68 degrees in 3 hours on a January morning. No electricity, no gas. Total cost, $18. Compare that to commercial solar thermal installation, $3,000 to $8,000. Same thermosyphon principle. Same copper absorber, same physics. The only difference is who profits. You can mount this on a window. You can build it into a south-facing wall. You can make a portable version for emergency deployment. You can scale up with multiple panels. You can integrate it with thermal mass storage. Total cost, under $25. Time, 1 afternoon. Copper conducts heat at 401 watts per meter Kelvin. The thermosyphon principle has worked for over 200 years. In 2021, the Texas grid failed. 246 people died because centralized heating has a single point of failure. FEMA's own classifications ensure the cheapest solution stays out of emergency infrastructure. But you're not FEMA. You're not waiting for permission. You're not depending on a system that proved it can't protect you. You now know how to build a $25 insurance policy against the next grid failure. The knowledge is the asset. The copper is just copper. The sun is free. The physics is settled. This works because it's simple. It's simple because it's physics. They can regulate installation. They can classify it as structural. They can make it bureaucratically painful. They cannot change thermodynamics. Send this to someone who heats their home with a system that has a single point of failure. Send it to someone who remembers what happened in Texas. Send it to someone who wants to know what works before the lights go out. The vault has the deep archive, every suppressed build, every buried technology, every piece of knowledge that threatens no one's quarterly earnings because no one can profit from it. That's the entire point. We're here because centralized systems fail and decentralized knowledge survives. You carry that knowledge forward now. Build the panel, test it, teach someone else. That's how this spreads. The next video covers water purification that costs $3 and outperforms systems selling for $300. Same pattern, same suppression, same physics that's been known for centuries. Stay ready, stay informed, stay independent.